Hi everyone, my name is Rohan. I am going to share my experience as a graduate apprentice at CMTI Central Manufacturing Technology Institute, Bangalore. I will also discuss about one of the most important project I worked on, the design and development of a eddy current displacement sensor. At CMTI, I worked in a research and development environment where we design and test advanced manufacturing technology. As a graduate apprentice, my role includes understanding the sensor technology, designing the circuits, performing experiments, testing and analyzing the data, working with measurement instruments. One of my main tasks has been working on eddy current based displacement sensor, which measures a very small distance with high accuracy. Before explaining my project, let me quickly explain the concept of an eddy current. An eddy current sensor works by generating a magnetic field using a coil. When a metal target comes closer to this coil, the magnetic field changes. This causes the inductance and impedance of the coil to changes, and from these variation we can measure displacement. These type of sensors are commonly used in robotics, CNC machine, automation, precise measurement systems. My project includes like a coil design. The first part of the project was designing the coil. I had to consider wire material, operating frequency, parasitic effects, core material, and coil dimension. All these parametric directly affects the sensitivity and accuracy of the sensor. After designing the coil, I set up a full testing circuit. This includes a signal generating with 5 volts peak to peak, an LC circuit, load calculation measuring the current, impedance, and voltage across the LC network. I calculated the values like impedance, load impedance, voltage, and total impedance to understand how the coil behaves at high frequency. Next, I perform testing to observe how inductance changes when a metal target moves closer to the coil. As expected, when target is near, inductance decreases and operating frequency increases. I verify all these results using an impedance analyzer. For a precise measurement, I used LDC1101 inductance to the digital converter, which is suitable for high frequency sensing. The coil we developed had around 24 microhenry inductance and about 10 microhenry when placed inside an housing. Like what I learned from this project, which helped me to understand the coil design fundamental, high frequency electronic sensor behavior, impedance analysis, practical testing using the lab instruments. It also improved my skills in documentation, experimenting, planning, and understanding the real world industrial sensor development. Being a graduate apprentice at CMTI has been a great experience for me. Working on this sensor project gave me hands-on exposure to advancement measurement techniques and real R&D works.